So I will be talking about explainable AI. I don't know why this is the title. I just realized it, and this is not a PC where I can fix it. Anyway, I will talk about explainable AI, not just about explainable planning. That's another topic. I'm really glad that Kirsten started this, ended her presentation with an important issue of ethics in AI. This is something what was, I would say, there's a lot of buzz currently. I don't know how any one of you was in touch that or not, but I think also in media you could have seen titles like these. There is a lot of attention about what is going on because AI is now applied to so many applications, and it's used more and more in real world applications and around people. And I think it got attention of different, let's say, different areas, not only researchers, not only computer scientists and developers, but also people who are just users, people who just have bank accounts, and in that sense also even people who work for governments, for EU, and etc. So what's going on about? So explainable AI, as it says, is referring to artificial intelligence that is explainable, but it's not also only about explaining, it's also about ethics questions, like Kirsten mentioned, which are very important, like how the data is being used, what is going on. So people are wondering how their data is used, for example, and for what decisions. Then also how decisions were made that maybe are affecting them. Or, for example, if we go to robotics, then it comes even to more questions about what AI will be doing and how robots will be incorporated into our world. So these are all topics that, let's say, XAI is about. And since this is quite a short presentation, I've just prepared, let's say, somehow overview. And later, of course, we can have more in detail conversation about it. So need for explainable AI. So why it came now? So why it became hot topic now? It is because just now we have AI algorithms that are working so well that are actually being used in so many applications. Now on, we have AI being used in transportations, in finance a lot, like big finance companies are using a lot of AI algorithms. When I say AI here, I usually use that because AI is not only machine learning, but also so many other algorithms, which probably I will not be having now time to focus on. Then we have security. Also, there are many military applications and many medical applications, like Kirsten was mentioning. And now we have AI systems that are actually maybe providing important predictions. They're even making this important decisions that are affecting people's lives, people's finances, and people's security. So we have now final users that can be any user, but also even for a developer, they can have these questions. So even the person who is a researcher and maybe did a PhD in computer science in particular area of machine learning, they still can have questions about algorithms they use. So, and some of the questions that can appear are like, why did you do that? Why didn't you do something else, for example, or when this algorithm will succeed, or why did it take so long, or just the questions, can I trust this system? So this is some questions that also are started going around many scientists, many researchers, many developers, everyone actually who uses AI. So what do we think here about? So here we have two representations of, let's say, AI algorithms. Not all of them, but we can always imagine like this. We have some input, we have some process that is going on in a black box, and there is some output that an AI system is providing for us. And this box is most of the time black. Like in the previous talk, we could have seen actually this is the case for the deep learning. We don't know what is going on inside. Even the scientists working on it most of the time don't know what is actually going on. Some algorithms, we can say they are partially known. There's some reasoning behind it to some extent. But as soon as it comes to more data and to more different scenarios, they also become so complex. So all those questions that I have already raised, they are actually asking, and they want that this process becomes transparent, so that we actually open this black box and we make it transparent for a user, at least in some sense. What does this mean? So we need to provide insights on the models, on the AI models, but also on the decision-making process that this AI is giving. So here I say decision-making process. This is not the only use, of course, of the AI system, as I guess you all know. But in the end, what the AI system did, it provided some prediction, some process, some plan. In the end, it's some kind of decision, or it's affecting someone's decision. And what we want actually is that we have some kind of model explanations, model that are being used for this process, that we can inspect models. I don't know if we have, if we want to go back and see decisions or history of the data, or at least maybe that we have some kind of additional explanations for the outcome. So we don't have to know maybe the process, but at least to in some way explain the outcome of the whole process. I will come a bit later in more detail, so I hope it will, for you. So these questions read so many events recently. I hope you had the opportunity to hear some of them. If not, I have put it here, so maybe you can go and check it out. Also, there will be a lot of happening going on in the future. So if any one of you maybe wants to attend them. So many researchers and many companies also started being interested in this. So there are already many publications going in this sense, towards this sense, and answering all these questions. I'm not sure how much you're interested in, but maybe you're more interested in the initiatives that are taken by different companies, mostly big companies that are actually affected, and the companies which are using these AI systems, usually using AI systems. So for example, you already have IBM working on it for a couple of years, then Fujitsu, Siemens, and so on. I would like to here just highlight one important challenge raised by DARPA. I don't know if you have heard of DARPA, but DARPA is Defense Advanced Research Projects Agency in US. So they are financing most of the research going on there. And also every couple of years, they have challenges they are giving for different research groups that can apply. Those are usually universities, but also big companies. And they are kind of boosting the way of how the technology is developing. So they were one of also who, I don't know, if you have seen a couple of years ago, there were going memes of robots who are falling down and doing some funny things. That's all from, for example, their research, because one of their challenges was also how to have a robot which is able to completely itself go around and do some rescue. For example, another challenge from them is autonomous cars. And one of the newest challenges is actually providing explainable artificial intelligence algorithms and making AI explainable to humans. Why do I mention them is this because this is something that many researchers and many companies follow up, and they actually give very good first initiatives and first concepts of how actually explainable AI should look like. So what did they imagine? So here they take, so their initiative was focusing first on the machine learning strictly. So that's what they focused on. So the standard process when you want to use machine learning, it looks like this. You have some training data most of the time. It can be small set or big set, like in the deep learning. You have machine learning process where you plug in this data. I don't know, you decide what are your inputs, outputs, what is your target. You train the model. You usually have some learn function, which is then doing some kind of prediction or decision. So you have some input, you have some output, and then you have a process. And then this is usually the product. And this is usually what is being used by a user. Now this user is just getting a decision or recommendation based on this process. And it can have many questions. As I mentioned, even like developers and people who are experienced with machine learning can have many questions. Like, for example, why did you fail? That is one of the most common questions I think all people used, like why this model doesn't work, why do you fail, or why do you fail in this specific situation when I expected you to actually work. So what they said, okay, now this is a current concept, and they said like, okay, let's change this, let's change the way of we are thinking and how we are seeing things. This is not enough. This is not enough because now we have AI, which is used in so many things. So now we need something like this. We need to have a process where we have a training data, we have a new machine learning process. I'll explain a bit later what this new has to mean. We have explainable model, and then we have also some explainable interface, which means now we have a user which can be completely, let's say, unrelated to computer science, unrelated to software. And this user even can ask questions and get explanations why decision was made as it was, why it was not made as it was expected, for example, or to know when the algorithm will succeed or when not, when it can be applied, when not. And very important, actually, if it can trust or not trust and when to trust the system. So what is XAI explanation? So if you look at machine learning system, and here in the example is neural networks because it's most common for everyone currently, and I think people are more familiar. So usually it has something like this. You have some network, you plug in a picture, and then you get the output. Okay, this is a cat. But this is everything what you get from the system. Instead of that explanation, what XAI explanation would be, okay, this is a cat. It has fur, whiskers, claws. It has these specific features that are characterizing cat. So that's why I suggest that in the picture, there is a cat. I hope you're already grasping the idea. So providing explanations like this is a multidisciplinary approach, because it's not only about algorithms that are making decisions about cats. So you have now also user interaction part. You have to think about users, what type of users you are speaking with, on which level of understanding they want to get an explanation. Also, what particularly they're interested in, are some groups are using it or not. That's why many actually sciences have been joined to start finding the solutions and providing algorithms that will provide some explainable AI. So most importantly here are, of course, philosophy, psychology, sociology, also law. There have been many regulations already settled. Then communications, teaming between computers and humans, teaming between humans and humans, and teaming between robot and humans. And of course, AI, because AI is the core here. So what would it mean for AI? It would mean that probably it should modify current algorithms and produce some new algorithms. Also, human interaction part will be very important, providing interfaces, meaningful interfaces, depending on the systems and depending on the current implementation. So as I already said, another important thing here is law and regulations. And this is something also that Kirsten has mentioned. And I think there was in discussion about it. So there already have been some attempts in this direction. And I guess you're all aware of them. I think, or I hope you already have heard of GDPR. If not, I will remind you here. I don't know, there was one day in May in 2018 where you got a bunch of emails, all of you, I guess. And then you had to confirm, what do I want? Do I want to continue this, I don't know, service app? Do I allow them to use my name, my data? Why is this what's going on? Because up to that date, all big companies, all services, even small companies, marketing companies, have been using your data for their, mostly for their recommender system models. And they were like using, okay, you were one unique in the bunch of data, and still your data was used to provide some recommendations, to provide, I don't know, some commercials to you, to recommend you products. I don't know, if you go on Amazon, you can see different things coming from these recommendations. I mean, these are just some examples of it. Of course, GDPR is covering much more, and I'm inviting you all to read about it, because this is something also what computer scientists should be aware about. So this is one important regulation. Another thing is that just appeared a few days ago. I don't know this is not so well resolution here, but if you can see here the date, it's 21st 4th, so which is just last week. This is a new suggestions of for the regulation of European Parliament on how actually regulating AI and mostly machine learning here. So there were some already in forums, on computer science forums, started some discussions on how actually EU is now regulating Bayesian networks and so etc. So this is another document I invite you to read. So I just wanted to mention here that there is already going a lot about regulating how actually AI algorithms can be used, and also defining what is expected from them and how actually people, all of us, all users are protected around AI systems. I'm not sure how much time I have. Okay, but let's continue. So what else I wanted to mention here? So now you can imagine, okay, what's happening. So we had so many applications. We have so many algorithms so far. So what to do with them? There were already some reviews, and this is one, let's say, the easiest overview. But you can go and read many articles about more in detail. But what is going on with already algorithms that we have? So we have already so many successful algorithms like deep learning. And what is very symptomatic is that those are most hardest to explain. They have the best prediction accuracy, but they're hardest to explain. On the other hand, we have algorithms such as decision trees, which are really easy to understand. And they are the ones, for example, with kind of transparent process, and we can grasp what's going on, but they are not giving such a good accuracy. So which means we have to either come up with new algorithms or to provide explanations for the ones which are working so well. So there were already many directions started, and there are already many, I don't know, research and developing going on in different directions. So that is the current idea, to use the existing ones, but also to develop completely new ones, algorithms from the scratch, having in mind all this what I have told you about today, and designing an algorithm, or designing algorithms that will actually provide the outcomes with explanations and with some model insights. So I'm not sure how much time I have, so I wanted to mention just few approaches that are already being taken. One of them, for example, for already existing algorithms, is taking the current algorithm and having in a parallel learning system or some other method that is learning explanation, and actually learning even explanations from the data provided by human. Like you have humans who are labeling some outcomes and giving explanations for the outcomes, and then you have a parallel learning system that is learning explanation. You can imagine that it's also not so much trustworthy, but in some sense it is. It all depends, of course, on the applications. Another approach that is being taken, as I already mentioned, is designing algorithms from scratch. Another example of this, for example, is this multimodal modular neural network, where they are providing on each layer an explanation, and they're giving interpretability of each layer of their network. Another approaches are going into exploiting what they already have and what was already part and outcome of their networks. I think people who are familiar with deep learning, they already know that if you analyze some slices of the deep net, you could get some meaningful information and see how the network is learning, which is already a benefit and a good thing. Just it has to be used in the right way to interpret and present to the user to provide some explanation. And I would like to finish this with what we are doing at King's. Unfortunately, I don't have enough time in 10 minutes to explain what I'm working on, like in many details, but we are working in King's at in many directions, actually, to provide explainable AI algorithms and going towards explainable AI. And then we have several research groups and going on in this direction. And things that we are working on are verification and texting. Then we are working on planning and explainable planning, argumentation and dialogue, which are very important part of this. Then norms and provenance. That is also something you haven't heard probably about, but we have, this is it's a very interesting research area where people are looking into traces of how actually the code was changing over the time. And then they can see, for example, how some changes, or not only the code, but also the traces of the whole system. And they can see how some changes in the system or some particular data had affected the outcome very late. Or even, for example, how some developer who made a change 2 years ago affected maybe the outcome now. And there's, of course, there is human-oriented AI. Thank you very much for your attention.